The other type of scoping that we actually mentioned before is dynamic scoping. And we discussed how, what are the semantics of how, how, what we mean to say when we say dynamic scoping. And the questions we have to ask ourselves are exactly the same questions. How do we find the actual variable or the frame that we actually are looking for, and how do we find the variable within that frame? Okay, so there are actually two ways how this is done. The first is pretty much the same idea, that we actually use a dynamic link which points one to the next, and it says, okay, we look at the runtime stack and we say, okay, main called, let's say, y, which called 25x's. We're going to keep with the example. Which actually called z. And inside z, we had our c out, right? That was inside z. And we actually say to ourselves, okay, now we have a dynamic, in a sense, a dynamic link. Now there's no real need for a dynamic link because it's always like that. It's always the parent, right? It's always, the dynamic link always like that. Who is your parent? The one who called you. So in a sense, there's no real use for this dynamic link besides just knowing where your parent began and where your parent ended, okay? And when we search, we could do what's called two different types of versions. We have what's called deep access, and we will talk about in a minute about shallow access. What is deep access? The idea behind deep access is very simple. You have to go searching. The compiler cannot help you here. Why can't the compiler help you? Because it doesn't know. It has no way of knowing during compile time, right, how far away the dynamic parent where the actual variable is declared is from where it is used. Notice that B is here, right? A was here. So A is one link away, while B is, I don't know, K links away, right? However, if you actually wanted to count, so we had 1 to get to X, we had 25 X's, that's 26. Go to Y is 27, go to main is 28. So K is equal to 28, and we actually have to search. Now, even once I get to the correct frame, where within the frame is the variable? What is the offset? Now, the compiler can't know that either, because it doesn't know which of the variables you're going to use. What I mean to say is that we saw in the original picture, right, that we had the variable B both in main and in Y, right? So when we actually go and search for the B, we go over these 27 links and we got to Y. Now within Y, we ask ourselves, is there a B here? Now, what is the answer to that question? That's a very difficult question. Go through during runtime. We don't even have the names, right? So even if you go and we say, okay, let's put the names into the activation record instance, but notice that the offsets for B in main and the offset for B in Y is not the same. Here we have an offset of whatever, and here we have a much smaller offset. So the compiler can't even help you as far as that's concerned. So you actually have to really keep and looking and searching. And we have to have all the names within the runtime stack, which is something which is not really standard. So that's actually one way of doing it, and that's not a smart way of doing it. And therefore, we're going to use what's called shallow access. So we have shallow access. What is shallow access and how does it work? What we actually do is for every variable, when we enter a scope and we have a new variable, we create a stack. So for example, we have a stack for all A's, and we have a stack for all B's, and a stack for all D's. And I believe we had a C also, whatever it is, we had a C also, right? And when we enter a scope and we see a new variable, what we do is we put the variable on the stack. So for example, we entered main had A and B. So we put the variable not on the runtime stack, but we put it on these side stacks. So we have A of main. I'm going to write main just because we should know who it is. And we had B of main. Now, from main, we went to Y. Y had, if I'm not mistaken, it had B and C, right? It had B and D. Y had B and D. So we go and we put on B, Y's B, and on D, Y's D. We pushed it on the stack. So there we went to X. X had a C and a D, I believe. It had an A and a D. So we put X1s on A and X1s on D. Right? Now we have 25 recursions of X. So we have 25, X2, and set it on until X25. Same is true for D. It goes until X25. They're all pushed on the stack. Okay. Now we go into Z. Z said A plus B. Which A is it and which B is it? The answer is look at the A stack. Look at the A stack, and you right away get the correct A. Look at the B stack, and you right away get the correct B. Right? You don't have to go searching for anything. It's in the top of the stack. So this was called as shallow access. I'm going to just go and push it on the stacks. And as I meet new variables, I push them on the stack. As I leave the scopes, right, I pop them off the stack. So for example, suppose that I went off X25. So X25 will pop off the stack, right? X25 will pop off the stack. And then suppose from X25, I went into Z again. So obviously this won't be here. Or this won't actually be here. So let's just skip it. And the link will be like that, right? So if I have here X24, here I have X24. And here I have also X24. And again, I say, okay, C on A plus B, no problem. A is X24, B is Y. So notice how it's in one step. This is a constant step. I am able to find the correct variables, the correct memory locations. This is known as shallow access.